Hello everyone, so welcome to our video lecture. Dear students, today we are starting our new chapter, that is reaction mechanism. Okay, now what this term reaction mechanism means? So first of all, we need to understand about carbon and its properties. See, in periodic table, the element carbon having atomic number 6 and mass number 12 is having lots of properties like catenation properties. It can form single bond, double bond or triple bond with different carbon atoms. It can form long chain of carbon atoms. Also, it can form open chain compounds or cyclic compounds, monocyclic or 3 rings, 4 rings, 5 rings and so on. It can also form bonds with other atoms like sulfur, nitrogen, halogens and so on. So due to these enormous properties, what happens? The carbon compounds, if I say organic compounds, then there is a huge amount of organic compounds present. So these compounds and their studies becomes a very difficult task. So what happens? We need to categorize all these reactions into different forms. Okay. Now one more question arises, what will happen when these compounds are interconverted into one another? So let me start with very basic example. Carbon. So if we simply say this is sp3 hybridized carbon atom having 4 sigma bonds. Now if I take the example of this compound, then this carbon is sp2 hybridized. See, it can form double bond as well, or this compound, this carbon is sp hybridized. Okay, now single bond, double bond or triple bond. Okay, suppose if I say in this compound single bonded also, so carbon is forming single bond with carbon, pi bond or triple bond with carbon atoms. Also what happens, due to these different hybridizations, the electronegativity of this carbon atom varies. And due to the variation in electronegativity, the polarity in between bonds is created. Okay, let me tell you, the electronegativity of simple this sp3 hybridized carbon atom is approximately 2.5, right? This is approximately 2.75. But when the carbon is sp hybridized, means the percent S character is increased. Here it was 25%, here it is 50%. Then the electronegativity is increased to approximately 3.5, even higher than nitrogen. Hence, such carbon atoms triple bonded are highly reactive. Clear? Now, this one. So polarity in between CH bond is maximum in this compound. Okay. Now let me tell you, carbon can form cyclic structure like benzene. This is your aromatic compound. It can form bonds with sulfur, like you can see this compound. Okay, it can form compound with nitrogen atoms like this one, pyridine. So due to all these cases, the study of organic compounds becomes a typical task. Okay, now what happens? If we see a simple organic compound CH3 single bond CH3, ethane. Okay, now this single compound can be converted into lots of different compounds by using different reagents. What it can be converted into, let's see. Simple oxidation gives this ethane into CH3 CH2 OH. Okay, now again small oxidation makes it CH3 CHO. Again it makes it CH3 COOH. Okay, now this is your oxidizing part, oxidation. Clear? Now if I take the backward part, you can see this carboxylic acid is reduced to aldehyde, acetaldehyde, acetic acid to acetaldehyde. It is reduced to ethanol, and now it is reduced to ethane. Clear? Now this part can also be made into ethene, right? So in all such cases also it can be made formic acid as well. So what happens in such a case? The study becomes very typical. So in order to categorize these things in particular topics such that we can study about the mechanism, properties, preparation and their uses in simple way, it has been categorized into a few type of reactions. Okay, so let us study about all those types of reactions, what are the reagents used and how these reactions are catalyzed in simple way. Let me take a simple example of CH3Br plus KOH. Now CH3Br plus KOH, it forms CH3OH plus KBr. Okay, so dear students, here you can understand it is a very strong base, so you can take it as K plus and OH minus. So it is our nucleophile. Okay, this is bromomethane, so this is our reactant. Okay, reactant is also called as substrate. Clear? Reactant or substrate. Now when this reactant is reacted due to this nucleophile, here this nucleophile is a attacking reagent. Okay, then this methanol, which is our product. See, in generally organic reactions, the desired product what we actually want to prepare is only studied. The side products whatever is furnished or produced, it not studied in detail. Okay, so mainly I will say it as desired product. Okay, and this is our side product. Okay, now here a few terminologies I am telling you. First of all, reactant or substrate is the compound. Basically we are dealing with organic compounds, so reactant or substrate is the organic compound which undergoes certain step of reactions. It may be single step reaction or multi-step reaction to form some desired product. Okay, now to initiate the reaction certain reagents are used, and based on those reagents the reaction is named. Okay, it depends which type of reaction will be carried out. It depends upon the reagent which initiates the reaction. Here if you see, the reagent is nucleophile, so this reaction will be called as nucleophilic reaction. Clear? The reaction may be occurred due to reagents like electrophile, which is generally represented as E plus. It may be due to nucleophile, which is generally represented as Nu or Nu minus. It may be due to free radicals. Okay, clear? So the reaction may be catalyzed due to various reagents. Clear? Now let us see about various reagents, and this is our side product. Here also you can understand one thing, this K plus OH minus, and here also K plus and Br minus, as it is also ionic. So the role of K plus here is nothing. So in this reaction K plus acts as a spectator ion which has nothing to do in this reaction. Okay, and Br minus is your leaving group here, leaving group which leaves after this reaction. Okay, done. generation of intermediates. Now dear students, you have to understand, in these reactions, organic reactions, it may be carried out in one step or multi-step. Okay, now what happens if the reaction is multi-step? Means from reactant to product, in between there is something else which is developed or generated in between the reaction, which is stable, which can either go backside to the reactant or it can form the product. Those parts are called as intermediates, which are formed in the reaction. So reaction intermediates. So how they are generated? Okay, see, first of all, let me tell you what are the intermediates. Suppose this is an alkyl group R which is connected to any group. As I already told you, this alkyl group which is having carbon with this group bond, this is definitely having polarity due to electronegativity difference between these two atoms. Now, there are possibilities that this can form R dot, which is called as our free radical, R plus, which is our carbocation, or R minus, which is our carbon ion. Okay, now if this bond is broken in such a way that the two electrons are distributed equally among the two, means one electron of this carbon goes to carbon and this group is taken away with one electron, then this part will be your homolysis. Homo means equal, lysis means breakdown of this bond with equal distribution of electron, and hence free radical will be generated. But if you make unequal distribution of electron such that both the electrons are taken away by this group, then you will be getting R plus carbocation. Okay, so this is your heterolysis. Clear? So this is heterolysis, means unequal bond breaking, means bond breaking with unequal distribution of electrons. Now suppose both the electrons are taken away with R group, then it will be R minus part carbon ion. This is also heterolysis. Okay, so dear students, these are various reaction intermediates produced in the reactions which we have to study in all the reactions. Okay, free radical, carbocation, carbon ion. Now I am telling you about two more reaction intermediates. Carbene. Now what is this carbene? I am just giving you one example. As you all know, this carbon is connected with hydrogen, chlorine, chlorine, chlorine. Okay, this is chloroform. When reacted with a base or concentrated base, if I say KOH, what happens? This hydrogen is highly acidic here, although it is connected with carbon. Why? Because if OH minus will attack this hydrogen, then H plus will be removed and you will get one carbon ion, CCl3 minus, okay, which is stable, resonance stabilized. So H2O, then one Cl minus will be removed, which will form KCl, and the remaining part is CCl2. Okay, now this is called your carbene. If I check that part, this carbon is having two electrons, one chlorine this side, one chlorine this side. The name of this part, see, as an intermediate it is carbene. Now if I say the name of this compound, this is species, it is dichlorocarbene, generally said as DCC. Okay, dichlorocarbene. Similarly, simply if I say carbene, then it can be H, H and 2 electrons. Clear to you? Okay, so this is one of the intermediate which we have to study. Okay, so dear students, I have taken just one example. It is KSH, means K plus SH minus, and this is your alkyl halide. Okay, now this is our desired product. This is our leaving group. Actually it is X minus, K plus is spectator ion, and this is your attacking reagent. Okay, clear? So this is the reagent which is causing the reaction, so it is nucleophilic reaction. Clear? Now I am taking you a few important points which we need to understand during the study of reactions. Okay, first part, role of solvents. See, generally what we understand about solvent is the one which is present in higher amount in the solution is solvent. Okay, now the solvent is also categorized into different types. The solvent is polar or the solvent is non-polar. Okay, so it depends whether the solvent is polar. Then what happens, suppose there is polar solvent and the intermediate generated in the reaction is also cation or anion or free radical. Then what will happen, that polar solvent can interact with the polar part generated in the reaction. Clear? Okay, and now suppose there is a solvent which is non-polar, just like CCl4 or benzene, generally used, most used solvents non-polar, CCl4, carbon tetrachloride or benzene. Then there cannot be any interaction of non-polar solvent with polar molecules. Clear? Because as we know, like dissolve, like means polar molecules will be dissolved in polar solvents like water. Clear to you? So there are important role of solvents. Next, role of catalysts. Now what is the role of catalysts? See, in many reactions what happens, the reaction will be initiated. Okay, there is no role of catalyst in initiating the reaction, but to increase the rate of reaction, catalyst can be used. Okay, now remember, the catalyst is also defined as positive catalyst and negative catalyst. Positive catalyst is one which increases the rate of reaction, while negative catalyst is one which decreases the rate of reaction. Okay, so we need to understand for all the reactions what is the role of catalyst in those reactions. Clear? Next, nature of intermediates generated. Now this also matters, what is the nature of intermediate generated. As I told you, in the reaction there is a possibility of single step reaction or multi-step reaction. Okay, so I'll tell you this one. Single step reaction, first of all understand. I am just giving you with an example of single step reaction. This is X and here you are taking OH minus and here you get this OH. Okay, and X minus is removed as a leaving group. Clear? This is your attacking reagent. Suppose this is a reaction which is occurring in one step, only single step. Then what will happen, as the reaction is only single step, so the rate will be defined based on this only, right? Rate of reaction. So now I am coming towards kinetics and energetics of the reaction. Okay, the rate of reaction for a single step will be dependent on the reagent and reactant. Clear? Now in every step of reaction there forms one transition state. Now what is transition state? Transition state, state between any conversion step. Means suppose if I am telling one step reaction, so in between reactant and product Intermediate part will be your transition state. There will be no as such reaction intermediate there because it is single step. So there will be transition state. So suppose if I have to understand the transition state of this one, what will be the transition state? See, the transition state will be like this. If we can understand, this is halogen, so it is your negatively charged. So this cannot attack from this side, so it will attack suppose from this side. Okay, from here OH minus is attacking, and you can understand from here this X as a delta negative charge, it is getting removed. So this is the transition state for this reaction, represented as TS, transition state. Okay, for every step of the reaction, from conversion of 1 into 2, there must be intermediate. Okay, suppose for this single step reaction, one transition state. Clear? See, here it is a category called bond formation. Okay, bond forming state, and here it is bond breaking step. So as such, this carbon is sp2 hybridized. Clear about transition state? Now let me tell you multi-step reaction. Multi-step reaction. What happens in multi-step reaction? Suppose if I say this reactant R converts into I. This is your substrate. This is our intermediate, and then here it is your product. Means I am saying desired product. Okay, so dear students, you can say, understand, this is first step, this is second step. Now understand a few points. I told in every step there must be transition state. So you can say for R to I there must be transition state 1, and from I to P there must be transition state 2. Okay, now for two-step reaction, 2 transition state and 1 reaction intermediate. Clear to you? Simply if I have to say 3-step reaction, then 3 transition state and 2 reaction intermediate. Now if I have to say 1-step reaction, 1 transition state and no reaction intermediate. Clear to you? Okay, now if it is a 2-step reaction, we have to understand the RDS step, means rate determining step. RDS step means rate determining step of the reaction. Okay, slowest step of the reaction will be RDS. Clear? So in multi-step reaction, always remember the slowest step of that reaction will be rate determining step of the reaction, RDS. Okay, now I was telling about in reaction mechanism, the nature of intermediate formed will also depends. Okay, so here the intermediate is generated. Okay, now the intermediate can be, what you can think, this intermediate can be 2 types, either electron donating group, means EDG, or electron withdrawing group, EWG, or it is also called as withdrawing or releasing. So electron releasing or withdrawing group, EWG or ERG. Okay, so the intermediate can be electron donating group or electron withdrawing group. Clear? Now on this basis, it will depend that how the second step will proceed. Clear to you? Okay. Now let us understand kinetics and energetics of the reaction. Kinetics is about rate. As I told you, one step reaction, rate will depend upon the reactant or maybe among the reagent. Now when multi-step, so we have to check the RDS, slowest step of the reaction. Now when it comes to energetics, energetics is all about the energy change phenomena occurring during the reaction. As we know, the reaction can be exothermic reaction or endothermic reaction. Now understand, students, in exothermic reactions, energy will exit. Energy exit means released. Okay, here energy required in, you can understand it says in, and it is understood as exit means out. Endothermic, in, energy is required, needed. Here energy will exit, liberated, released or liberated, and here required or needed. Clear? So reaction can be of these endothermic or exothermic types. We have to study all the cases in all the reactions. Now the thermodynamic phenomena will also generate. As we know, delta G equals to delta H minus T delta S. Okay, this is your Gibbs free energy change. That is your enthalpy change of the reaction, temperature and entropy change of the reaction. As we all know, if the delta G is negative, then the reaction is spontaneous. So we have to study about the thermodynamic phenomena of the reactions as well. Okay. Now when we study about energetics, we discuss about energy profile diagram. Now what are energy profile diagram? When we say energy profile diagram, here we simply means about the energy change phenomena occurring in any particular step or throughout the reaction process. Okay, so let us understand a small case. The reaction is conversion of R to P, one step, one transition state, no intermediate. Okay, and suppose if I am telling the reaction is exothermic. Okay, now when you say the reaction is exothermic, it simply means earlier this is your energy. Okay, and this is your reaction coordinates. Suppose this was the energy of the reactant. So from this graph you can understand this is ER, energy possessed by reactant, and this is EP, energy possessed by product. So student, you can understand from this graph that the energy of reactant is higher than energy of product. Means in this reaction some energy has been released, so it is exothermic, as I told you. Okay, so the difference between this energy and this energy is known as delta H, change in energy, enthalpy of the reaction. Okay, so I can mathematically say delta H can be represented by EP minus ER, where EP is said as energy possessed by product minus ER, energy possessed by reactant. Okay, now understand one more term. See, this much energy is possessed by the reactant, but the additional amount of energy required to convert this reactant into product is called as your activation energy. Okay, As it is for forward direction, so we call it as EAF, activation energy for forward reaction. Now, if the reaction goes back in the same way to from product to reactant, then the required energy from product to reactant will be EAB, activation energy for backward direction. Clear? Now, in these terms, if I have to say, see, exothermic, okay, EP value is lesser, ER value is higher. So this is your negative. As we know, exothermic reactions have delta H negative, okay. Energy is decreased, so negative. Also, we can understand this as EAF minus EAB always. So you are having two formulas to calculate this, EP minus ER or EAF minus EAB. See, EAF is this part and EAB is whole part. So EAF minus EAB, this part will be delta H, and the sign smaller value, larger value, it will be negative. So you can understand from this one or this one. So this is a reaction, okay. Now, as the reaction is one step, so it converts directly from reactant into product, and this is your transition state. Clear to all? Okay. So this is a graph drawn for exothermic reaction. I think all of you have understood. Okay, so let us study about these two graphs to understand the energy profile diagram for any reaction. Okay, this is energy and this is reaction coordinate. Here it is converting from reactant into product. Okay, now this is one step reaction. As you can see, from reactant to product directly. This is a transition state, one transition state. So one transition state, no intermediate, one step reaction. Energy possessed by reactant is lesser, energy possessed by product is higher, so it is delta H, EP minus ER, it is positive, so the reaction is endothermic. Now let us check EAF and EAB. EAF, EAB. Okay, so as I told you earlier, delta H can be evaluated as EAF minus EAB. Now you can check, EAF is higher, EAB is smaller, so it is larger value minus smaller value, so it is positive endothermic. Clear to all? Now let us understand this one. This is energy reaction coordinate. See, here I am just telling you about basic examples of energetics or energy profile diagram. Okay, we will be studying about these such kind of energy profile diagrams for various reactions in organic chemistry. For this is your reactant, this is your product. Now here you can see in this graph, from reactant it is converted to something called intermediate here. Okay, and then this intermediate is converted into product. So this is your transition state 1 and this is your transition state 2. So you can see here the reaction is actually from reactant to intermediate to product. So it is two-step reaction, one intermediate, two transition state. Okay. Now, if you have to check whether the reaction is endothermic or exothermic, simply check, this is EP and this is ER. Energy of reactant is lesser, energy of product is higher, so it is endothermic. Energy has entered, increased. Okay. So EP greater than ER, delta H positive, the reaction is endothermic. Clear to you all? Okay. So I think you must have understood about this. Now let me define you a graph which shows catalyzed versus uncatalyzed reactions. Okay. From reactant to product, this is energy and this is reaction coordinate. Clear? From reactant to product. Now what happens here? This is simply your uncatalyzed reaction. Okay, uncatalyzed reaction means you have not taken the catalyst in this reaction or in this conversion. Now if you take a catalyst, what happens? What is the role of catalyst? Catalyst can never initiate the reaction. Remember, catalyst can only decrease the overall activation energy of the reaction, and hence the reaction rates increased. If I have to draw from the graph, you can understand it will start from here only, it will end here only, but the graph will go like this. Means see, what is the difference? Here you need this much of threshold energy, ET, and now it is ET dash. Okay, now I am using another term, threshold energy. Threshold energy means ER plus activation energy of forward, means the total amount of energy which must be possessed by the reactant for this conversion into product. Total amount of energy means the potential energy possessed by reactant plus the additional amount of energy which must be given to the reactant, that is activation energy. That total is threshold energy. So the threshold energy is decreased due to taking catalyst. So this is your catalyzed reaction. Okay, increases rate but can't initiate the reaction. Clear? Remember this thing. Okay. So whenever I am saying catalyst, remember I am talking about positive catalyst. Okay. So whenever you are mentioned about negative catalyst, it will specifically say that you are having negative catalyst or poison or something like that. Okay. Now dear students, let us study about types of reactions. What we are going to learn in this chapter. In entire organic chemistry, those all conversions I started in this chapter, I started with the topic like an organic compound can have lots of reactions. Okay, it can have lots of conversions, and for those conversions certain inorganic compounds are used that can be oxidizing agents or reducing agents, or it may be acids or bases which initiates or which are involved in these organic reactions. Okay, so all those conversions or reactions are categorized into 4 particular types. Okay, first, substitution or displacement reaction. Clear? Second, addition reaction. Third, elimination reaction. And fourth, rearrangement. Okay, so that all the types of reactions which we study are categorized into basically 4 types. These types: substitution. In simple mathematics, as we know, substitution means one part is substituted by the another group. Okay, addition means to add on, one compound is added with any particular atom or group. Elimination means to remove some particular atom or group from a molecule. And rearrangement is simply shifting or ring expansion on all those cases. So let us take a single example of all these cases to let you know what is substitution, addition, elimination and rearrangement. Okay. Substitution reaction. Dear students, if you check the earlier reaction I used, both the reactions I used were substitution reaction only. Okay, let me give you an example. If I say CH3 CH2 Br bromoethane reacts with KOH to form ethanol plus KBr, then this bromine group is substituted by this OH minus group. So it is your Br, this is your leaving group, this Br is a leaving group, and this is your attacking reagent. This is your substrate, okay, this is your desired product, and this is your leaving group. Clear to you? So this is a simple example of substitution reaction where this attacking reagent, what happens? It is a nucleophile. It is having more electron density, electron rich species. It will attack this carbon atom which is having delta positive charge. Why? Due to the polarity between this carbon and bromine atom. Okay, and then this bromine will be removed as a leaving group. Clear to you? One thing to be understood here is among OH minus and Br minus, if I see, then Br minus is more stable. I am telling you about stability. Stability of Br minus is higher. Okay, that's why this reaction will not go in backward direction. Clear to you? Okay. Addition reaction. Now just simply understand what is addition reaction. See, from this compound to this compound, water is added here. So it is simply addition reaction. Okay. If I take HBr, what will happen? H and Br. Okay. So dear students, here you can understand it is addition reaction. Clear? Now, we need to understand this addition reaction can be, it may be electrophilic, or it may be nucleophilic, or it may be due to free radicals. So it depends whether the reaction will be proceeded, depends on how the reaction is initiated, and the reaction can be initiated due to electrophile or nucleophile or free radicals. Okay, so on that basis the reaction can be electrophilic or nucleophilic. Here, as we know, it is nucleophilic. Alkenes are nucleophilic in nature. Okay, and so this is electrophilic addition reaction. Why? This acts as a electrophile here, and this is also acting as a electrophile here. First of all, H plus will be added, then OH minus. So the reaction is named on the basis of attacking reagent used. Okay, so this is simply an example of addition reaction. Now let us take an example of elimination reaction. Now what are elimination reactions? Elimination reactions are simply when you eliminate or remove some particular atoms or groups from a compound. Okay, see, if I have to say and I am taking here minus HBr, and this forms CH2 double bond CH2. In this reaction you can understand that from this carbon bromine is removed, and from this carbon this hydrogen is removed. So HBr is removed. So this is simply your elimination reaction. Okay, elimination can be of various types. If I say this one, you have removed here hydrogen bromide. So it is simply your dehydrohalogenation reaction. Okay, dehydrohalogenation reaction. Now I am telling you one conceptual part. In earlier part I told you about addition of HBr, that was hydrohalogenation reaction, and now it is dehydrohalogenation reaction. So actually you can understand as addition and elimination are actually reverse of each other. In simple terms we can understand as. Okay, so this is dehydrohalogenation. Clear? rearrangement. Now I am just giving you a simple example to understand what can be the rearrangement case. Okay. See, in this case what happens, this H plus is a electrophile and this OH having lone pair is a nucleophile. Okay, so if I see, one intermediate will be generated due to removal of H2O. Okay, R, CH, double bond CH, CH2 plus. Clear? How? This oxygen will, this H plus will attack on this nucleophilic center, then this will be H2O, then this H2O will be removed, and here you get a carbocation as an intermediate. Now as we know, here it is having resonance, so you can get this carbocation will be generated. Okay, so actually from this carbocation to this carbocation is a resonance. Now as you removed the H2O earlier, now it is just H plus as a reagent used. Okay, now again you are having H2O, so this H2O as a nucleophile, it will attack on this carbon having plus charge. So what you will get, H2O is attacked and H plus is removed, minus H plus. Okay, this H2O will attack here, then this O bonded with carbon and 2H, so oxygen will get plus charge, so H plus will be removed, so you get this one. Now if you observe these two, what you will find is, earlier OH was here, now it has rearranged to this part. You can see this is simply a basic example of rearrangement. Okay, so we will be discussing about rearrangement in carbocations and various type of rearrangement cases. Now I am explaining you two more cases, okay, which is generally used in organic reactions: oxidation and reduction reactions. Oxidation and reduction. Here you can see, if you take any oxidizing agent, then this aldehyde can be converted into RCOOH. So this is simply your oxidation reaction. We will discuss about various oxidizing agents, including many organic oxidizing agents. Then reducing agents, it will convert this into RCH2OH. Depending upon the reagent, it may reduce it into alkane. Okay, now reducing agents are various agents which are used mainly organometallic compounds, like example here LiAlH for lithium aluminum hydride is used as one of the best reducing agent here. Clear? So this is one of the famous reaction we have to study. Last case, pericyclic reaction. Now see, in various reactions we will come across pericyclic mechanisms. So I am just giving you an example of pericyclic reaction. Okay, any group, and this is also any group. Okay, so dear students, here what will happen, it is having double, single, double type conjugation. So suppose it will resonate like this. What you will get, first of all, understand the reagent. Group, group, double bond will come here, this will get minus charge here and plus charge here. Now in this situation what will happen, this minus charge will attack on this plus charge carbon, and what you will get, you will get okay, see, this was open chain compound and now you got closed chain or ring compound. Okay, so we will discuss about all these things in detail. So students, it was all about basic introduction of reaction mechanism, about what are the reaction types which we are gonna study in detail. Okay.